So as we have the patterns created, like just assume as um, routing table, we have longest prefix match, right? So same way here, it will use the patterns, and if it finds a pattern which exactly matches or matches the destination closely, it will route it to that location and not to all others. But in case of like overlapping patterns, it can have unnecessary traffic. So yeah, we will come to that point. So here we were discussing about the loop prevention. So to prevent the loop, there is a search tag which is used. So using the search tag on a call to identify the repeated request for the small call, the search tag is created on the originating expressway itself from where it starts the search request, and it is then passed with the search request to the other expressways, and by having the search tag, which remains the same for all the search requests, the receiving expressway can then check if it has already received that search request with the same search tag. If it has already, then it can ignore the other request coming up further with the same search tag. So that can prevent the loop detection. So this is just simply a mechanism in the expressways to avoid continuous loops in case of neighbor zones. So then comes a structured dial plan. Here we can see. So for structured dial plan, each location use a unique identifier code, like these codes which we can see here. These are called unique identifier codes. And the dial plan of the device is prefixed with a unique code. So because of this unique prefix, all the devices that are registered, for example, in Dubai, will register with a prefix of 5971. Yeah. This configuration will allow all the Expressway C servers to route the search request to specific Expressway C server based on the prefix, rather than sending it out as search request to all other locations. So then it will prefer the flow, or the call flow will be based on the prefix first. If it finds the specific prefix, it will only send it to that particular location and not others. But without this use of unique identifier code, it would go to all the neighbors, as we discussed earlier. Yeah, so this is an enhancement to it. To the flat dial plan, we can have a structured dial plan with the use of prefix, a unique prefix, which is called unique identifier code. Yeah. So here in this configuration, it will allow the Expressway servers to route the search request to specific Expressway C server based on the prefix, and it will not send out the search request to all other locations. And this approach reduces the amount of traffic and unnecessary search requests that are sent and then processed. So that saves a lot of bandwidth as well. Then this is a complex video network with a structured dial plan, which also works with SIP environment where you use subdomains. So you can use subdomains also, like we have seen here. So subdomains can be used to identify the location of the device again instead of the unique identifier codes. This is again one of the way. So when the dial plan is structured, you can route calls to the correct locations. However, there is still a problem with this scenario in large environments that have many Expressway C servers. So if you have an organization that has many, like tens of servers, and you want to add a new Expressway C to the network, then you need to neighbor each of the Expressway C server to the new Expressway C, and neighbor the new Expressway C to each of its existing expressways. So this configuration will become a massive administrative overhead and will add some complexity to the network. So then comes hierarchical topology with structured plans. So this is the solution for large organizations with significant or large number of Expressway C servers to use a hierarchical topology with a structured dial plan. So with hierarchical topology and a structured dial plan to work, you need to understand the concept of optimal call routing, how it works. So optimal call routing is a setting which we configure on Expressway to ensure the shortest possible route for call signaling. So in this scenario, we can see Expressway A, B, and C are neighbored together in a chain with no direct neighbor relationship between Expressway A and Expressway C, but to one another, like Expressway A to Expressway B and Expressway B to Expressway C. So if endpoint 1 wants to call endpoint 2, the signaling passes through the expressway servers A, B, and C. With optimal call routing, expressway B recognizes that there is no need in the call and drop out the call. So the signaling pass directly between expressway A and expressway C. So it is better to perform and to configure optimal call routing, which finds the shortest path, which we can configure on the expressway. So if optimal call routing is not enabled, then all call signaling will go through expressway B, which would be an unnecessary traffic and traversal of the media, which creates some extra or unnecessary step or configuration as well. So depending on the location of expressway B, this extra step may involve the traversing of the network. So the call signaling of HTTP call, for example, the RAS messages we discussed, the request admission status messages, which are passing through all three expressway C, but subsequently the message types like the H.225 or H.245, the negotiation messages that we discussed are exchanged, should be exchanged directly between expressway A and C. So this behavior also occurs for SIP calls in case when we have a SIP invite with SDP information, which is supposed to be shared directly between the two endpoints or two expressways here, like A and C. So just in short, the solution to this is using optimal call routing here. So using the shortest path. So it is good to understand optimal call routing. So you can create a hierarchical topology like here, we can see this is a hierarchical topology. Each location has a local expressway C that is neighbor to its regional expressway C, and the regional expressway C devices are neighbor to one headquarter expressway, which is called here as World Expressway. So the dial plan will create each region and location to have a unique prefix. So we have this concept of prefix that we discussed earlier, as well as we have a hierarchical design here. So for example, if Beijing is neighbor to APAC, expressway C between the expressway Cs of APAC and Beijing. So Beijing has a location code of 001, APAC has a unique code of 003. This configuration means that all device addresses in Beijing will be prefixed with 003 and then 001 locally within the region. Let's suppose in APAC, there are two of the locations, Beijing and Singapore. So for each region also, there is a different prefix being used. So by using that, whenever a prefix is 003, 001, it can route it to Beijing instead of sending it to others. And if it is 003, 002, it can send it to Singapore. So with the use of these prefix codes and with the help of optimal routing, it can make it better and structured dial plan. So by structuring the dial plan in this way, a user in New York, for example, who calls his colleague in Beijing and dials the number 003, 001, and then its extension, the original extension is 1234, for example, this number right here. Right, where the device address is 1234 and the rest is the prefix before that. Yeah, and these are used for the structured dial plan 003 as an identification of the region, and then the location here 001. So this call would go to the local New York expressway, which will then recognize that the address is not in its local zone. So the call will be passed to the regional expressways. The Americas Expressway will identify that 003 code is also not in its region and pass to World Expressway C. So what will happen? The World Expressway C will then route the call to APAC, finding from its database, from its table, that this belongs to APAC region, and then it will route it to APAC. Then APAC will search based on the prefix and it will route it to Beijing. Yeah. So that is how it works. Without optimal call routing, this call would go through all the five Expressway C servers that we see here in the call path. But with the optimal call routing enabled, the regional and the World Expressway C servers will drop out the call path and the signaling will go directly between the New York and Beijing in this case when the call is being connected. The media will go directly between the endpoints, like we discussed in RTP, RTCP. Now, remember that for this routing to work, there cannot be any firewall preventing the communication because that would then become a traversal subzone and not neighbor zone. So that has to be considered here. There cannot be any firewall preventing the communication between all these networks. And this is a hierarchical topology that can work for subdomains and numerical dial plans. The routing is simply based on the dialed subdomain rather than the number prefix in this case. So here domains are used. So either you can use prefixes or separate domains. So it should be like unique structure. So if you have good subdomain dial plan, then DNS would be required in this case to make it more efficient to route calls between the Expressway C servers in each location. So additionally, if we are using domains, then DNS would be required.